I found this $60 soundboard. I'm gonna take it apart, take a look inside, and see if I can figure out which of these two reviews is accurate. Is it perfect or is it junk? At $60, I don't expect much quality inside here, but I do expect to find some good value engineering. So let's pop this open and void some warranties. There are a few design elements of the system I want to find and analyze. First, I want to follow the signal path from the input line in all the way out through the speakers. And I want to find out how are they amplifying and signal conditioning this input signal. I'm also curious to know how the engineers implemented the Bluetooth and the phantom power, which should have 48 volts out of these XLR inputs, and the digital effects. There's reverb and all sorts of digital effects on this. We'll also keep an eye out for what chips they're using. Honestly, I would be shocked to find a name brand op amp in here. And I'm also curious to see what other techniques the designers used to get the cost of this so low. It's really impressive they were able to do this for only $60. They took no risks on the mechanical design for this thing. There are so many screws in this. All right, that was the last screw. Let's see what this thing looks like inside. Okay, it's just one board, but we got more screws to take out. I was really expecting to see multiple boards. There's so many different systems here that it potentially could make sense to just cobble some things together, but they went for one board here, which means they designed it intentionally from day one to be a soundboard and not a Bluetooth module on a sound module. With audio designs, the PCB flexing can actually create electrical noise in the system, so I suspect that's why they went so hard on the mechanical engineering front to just lock this board down, keep it from flexing at all. And oh yeah, look at that. That is beautiful. So the first thing I see about this is it is one board. And the bottom, something interesting here, there are no components on the bottom of the board, and it looks like it's fully ground plane. So the ground plane means the shielding should be really good and you're not gonna get much EMI noise into your system. And because there's no components on the bottom, you don't have to flip it over during manufacturing. Your pick and place can do everything on one side. You don't have to have the jigs and everything to flip the board and get it aligned and get components on the backside. It's less good to have one board for repair and repairability versus having multiple components on the board. If you had multiple boards, you could just test them and chunk them if they didn't work, but because everything is all on one piece, we're likely gonna come across some evidence of repair as we look through this board. But first, let's trace the signal path. Your audio signals like your mic or your guitar are gonna come in through these XLR connectors, and what we have up here is phantom power circuitry. So when you push these buttons, you're gonna get 48 volts, and I wanna dig into that 48 volt system in a little bit, but first let's follow the path down through these op amps. These are 4558 chips, so kind of your standard op amp. I was hoping to see some better preamps in this system, but at $60, what are you gonna do? There's some kind of off-brand op amps really all over this board. They're in the preamp system, but we also see them for the EQ, for the mains. Really anywhere there's a potentiometer controlling a voltage signal, which is a lot on a soundboard, we're gonna have one of those 4558 chips. So we have a gain potentiometer here, which controls these op amps, and then we have the high, mid, and low EQ knobs for each channel. And what it looks like is these are essentially just a bandpass filter. So we have roughly the same circuit multiple times for the high, mid, and the low, but they've changed out the capacitor and resistor values to change the frequency ranges that those potentiometers control. And following the signal path out of the EQ section, we have the aux and the effects channel. What this aux potentiometer is gonna do is send a signal out over here into the aux section to control like a monitor that you have on stage. And the effects control is gonna go into the effects and then essentially back through. And this potentiometer is gonna basically mix in the effects from the effects section, but we'll look at the effects in a minute. After that, we have a couple LEDs and a mute button. The mute button is just gonna hard connect the signal to ground, and then that also goes into our fader. This controls the master volume for that channel, and that will then go into our main system out. One interesting thing I noticed in here is this peak LED. That essentially tells you when your signal is clipping, when your op amps are clipping. There's a whole separate signal path here that drives that LED. In a fancier soundboard, you'd see a full kind of VU meter where you'd see your signal, but in this case, with a kind of cheap board, it looks like it's just a light that flickers on or off if the signal's too loud. So that's our signal path start to finish, but this board has a ton of whiz-bang features, so let's check out the Bluetooth. Looking at this chip, it's an AB5323, which gets used a lot in like FM transmitters and other types of things where you want to connect your Bluetooth device to another audio system. So what it looks like is happening, and you can even see it in the silkscreen on this board. They basically dropped in a reference schematic for the AB5323 chip. We have the antenna here, and there's no ground underneath it, so when you look at the back, there's a nice little space here with no ground. That's so the antenna keeps working. You don't put it effectively in like a PCB Faraday cage. And if you look at the crystal here, there's a couple spots for capacitors to help that thing resonate, but they're unpopulated. So I suspect what happened is that they put it in, it wasn't oscillating, they took the capacitors out in the R&D process, and it started working. I've had that happen before. Crystals can be notoriously a little finicky like that, so I think they just left them off and it worked fine. It's a funny little find in this board, but hey, if you don't need it, you don't need it. The other part of this Bluetooth segment is some very creative height management. You see it for these buttons, you see it for the display, and you also see it for some of the other buttons on the Phantom Power, and we'll get to the Phantom Power, don't worry. They basically have through-hole LEDs on the Phantom Power and these other LEDs to hold them up and give them some security, hold them through the board, instead of mounting the LEDs all the way up against the board, which you might be tempted to do. This board also has some built-in digital effects, some DSP, and that's all driven by this microcontroller here. They have lasered it off, and it's pretty common to see lasered off parts so that people don't come back and try to reverse engineer your board. So I'm a little bummed we don't get to see what chip they decided to use, but we can see it has its own crystal and all sorts of communication lines coming into it because every channel needs to send for effects, it sends it back. It's also driving this little display here so you can tell what effect is running. And finally, what I noticed on the effects circuit is this little voltage regulator here to make sure it's getting clean power. And that's separate from the rest of the power on the system, which is an interesting design choice. Maybe they're trying to keep the noise out of the audio channels. Another part of this board I absolutely love is the master EQ section. We had high, medium, and low for each audio channel, and we saw how those each ran through a 4558. We see the same thing here, but with more granularity. We have these little slide pots here. These are potentiometers, just like our twist potentiometers. And each of those has a very similar set of circuits. It's all the same design, but again, they're swapping out the passives to give it a different frequency range that slide potentiometer controls. Really beautiful and elegant layout here, 10 of 10. As we move lower in the board, we have the VU meter here. Like I said, I really want to see these for each channel for the gain, but what are you going to do on a $60 board? Each of these chips is a KA2285 that drives one LED. This is a super fun little chip. All it is meant to do is take an audio signal or a voltage signal in and then display a VU meter out. So each of these LEDs, there's a pin for each LED, so it has the integrated driver in there as well. So this is a very cute and probably benign section of the board, but something that might be a little more dangerous is the Phantom Power. So it's time now to take a look at this 48 volt output. In the world of audio, sometimes you need to run a microphone or something else on power, and instead of having to plug that microphone into the wall for power and have its own AC system, it comes right out of the board, right through the cable. And 48 volts is pretty high voltage. If something goes wrong here, we'll see electrolytics blowing up and some other smoke being let out of the system. So let's see how they've implemented this. So to get to 48 volts, we start with our 12 volt inputs, and that 12 volts comes over to this little chip hiding over here. And this is a 34063 chip, which looks to be a boost converter. We have some magnetics around it, including an ES1G diode, which is a high voltage diode, and that confirms for me this is how we're getting to 48 volts for Phantom Power. However, I don't love that I can't see any name brand chips or capacitors around this, so I might be a little concerned to hook up my nice guitar to the soundboard. Who knows what could happen with that high voltage coming through. But at the end of the day, the design implementation of this chip looks really solid, so it's probably okay, just I wouldn't hook up your one-of-one custom-made guitar to it. Also, when I look at these connectors, you'll notice there's spots for screw mounting. This again helps solidify the board so the flex doesn't create more noise in the system. And connectors that connect physically like this at the top and the bottom are something you see on really high-end soundboards as well, so it's nice to see that. If we move over here, we have our general output. All of these signals are driven by our aux and other sends over here. It's pretty much a rinse and repeat of what we saw with the 4558s throughout the board. So again, some good modular design. They had their expertise and they stuck to it. I would like to see a better power system though. This is just a DC input and it uses one of these standard wall warts. And this thing doesn't even have a ground plug, which I guarantee you going to be a nightmare for sound people trying to get good sound out of this $60 board. However, from a design perspective, this is actually pretty clever because you can put any region's power supply at the other side of this. All it needs is 12 volt in. So if you're running 220, 110, 50 hertz, 60 hertz, it doesn't matter. You can just throw in a different AC to DC converter. And instead of putting it on the board and adding cost and adding weight and adding noise, you just do it all in this. At the end of the day, it's really quite the engineering feat to make this only a $60 soundboard, and there's some clever design techniques like the Bluetooth section, the no components on the backside decision, but I would have liked to see some better capacitors and some better op amps in here. If you're designing a board like this, I always find it's worth it to get authentic components. Go to Mouser.com, get your components there, and avoid surprise failures in the field. Thanks for avoiding the warranty with me today. I'm Daniel Bogdanoff, and I'll see you next time.